Welcome to Tech Zone for GATE series program. So with the continuity of series, subject is EDC day 7. So the question here is, as per the body effect in a MOSFET, the change in threshold voltage due to substrate bias is option A directly proportional to substrate doping, option B directly proportional to a square root of magnitude of body bias voltage, option C directly proportional to a square root of substrate doping, option D inversely proportional to substrate doping. Now we'll see next. So the question here is, consider an n-channel MOSFET at Vg minus Vt is equal to 3 volt and Vd is equal to 1 volt exhibit a drain current of 2.5 into 10 raised to minus 4 ampere full stop. If Vg minus Vt is equal to 3 volt and Vd is equal to 4 volt, the drain current is fill in the blanks into 10 raised to minus 4 ampere full stop, where Vt is threshold voltage of the MOSFET. Next. So the question here is, an ideal n-channel MOSFET has an inversion carrier mobility μn is equal to 500 centimeter square per volt second. A threshold voltage Vt is equal to 0.5 volt and an oxide thickness TOX is equal to 40 nanometer full stop when it is biased in saturation region with VGS is equal to 5 volt having ID saturation is equal to 6 milliampere, then the ratio of W by L is fill in the blanks and answer should be up to 2 decimal places full stop. Assume relative permittivity of oxide is 11.7. Now we'll see next. So the question here is, assume a MOSFET is working into saturation region whose current voltage relationship is given by ID sat is equal to Kn under bracket Vg minus Vt whole square and part of transfer characteristic is shown in the below figure full stop, where Vt is threshold voltage full stop. The device parameter as Kn is fill in the blanks microampere per volt square and answer should be up to 2 decimal places full stop. So this is the characteristic given here. Now we'll see next. So the question here is, if the internal condition inside the MOSFET is as shown in the below figure full stop, as per the channel length modulation, if Vg greater than Vt, MOSFET operates at option A pre-pinch off with Vd is equal to 0 volt, option B pinch off with Vd is equal to Vd saturation, option C pre-pinch off with Vd less than Vd saturation, option D post pinch off with Vd greater than Vd saturation. So this is the figure given here, and by this way this is the end of the question for the day. All the best.